Hello dear students. In this video I am going to discuss about connection oriented transport. The protocol is Transmission Control Protocol, TCP. The TCP connection. TCP is said to be connection oriented because before one application process can begin to send data to another, the two processes must first handshake with each other. The TCP protocol runs only in the end systems and not in the intermediate network elements, that is, routers and link layer switches. The intermediate network elements do not maintain TCP connection state. A TCP connection provides a full duplex service. Full duplex means communication in two ways at the same time. It is a two-way communication at the same time. Okay. Consider an example. If there is a TCP connection process between process A and A on one host and process B on the another host, then application layer data can flow from process A to process B. At the same time, application layer data flow from process B to process A. A TCP connection is always point to point, that is, between a single sender and a single receiver. Here, multicasting is not possible, that is, the transfer of data from one sender to many receivers in a single send operation is not possible with the TCP. Let's consider an example. Suppose a process running in one host wants to initiate a connection with another process in another host. The process that is initiating the connection is called the client process. The process that is initiating the connection is called client process, while the other process is called server process. Client process and server process. The client application process first informs the client transport layer that it wants to establish a connection to a process in the server. A Python client program does this by issuing the command, that is client socket.connect, server name, server port, where the server name is the name of the server and the server port identifies the process on the server. Okay. TCP in the client then proceeds to establish a TCP connection with TCP in the server. The client first sends a special TCP segment. The receiver responds with a second special TCP segment. And finally, the client responds again with a third special segment. The first two segments carry no payload, that is, no application layer data. The third of these segments may carry a payload. Because three segments are sent between the two hosts, this connection establishment procedure is often referred to as a three-way handshake. Three-way handshake. Once a TCP connection is established, the two application process can send data to each other. Let's consider the sending of data from the client process to the server process. The client process passes a stream of data through the socket. See here, socket. Once the data passes through the socket, the data is in the hands of TCP running in the client. Okay. Once the data passes through this socket, the data is in the hands of TCP running in the client. As shown in this figure, TCP directs this data to the connections send buffer. Yeah, this buffer, right? Connection send buffer, which is one of the buffers that is set aside during the initial three-way handshake. From time to time, TCP will grab chunks of data from the send buffer and passes the data to the network layer. Here, the maximum amount of data that can be grabbed and placed in a segment is limited by a maximum segment size. Maximum segment size, that is MSS. The MSS is typically set by first determining the length of the largest link layer frame that can be sent by the local sending host, and then setting the MSS to ensure that a TCP segment plus the TCP IP header length, that is typically 40 bytes, will fit into a single link layer frame. The MSS is the maximum amount of application layer data in the segment, not the maximum size of the TCP segment including headers. Okay. TCP pairs each chunk of client data with a TCP header, thereby forming TCP segments. The segments are passed down to the network layer where they are separately encapsulated within the network layer IP datagrams. The IP datagrams are then sent into the network. When TCP receives a segment at the other end, the segment's data is placed in the TCP connection's receive buffer. It is shown in this figure. Okay. The application reads the stream of data from this buffer. Each side of the connection has its own send buffer and its own receive buffer. See here, send buffer and receive buffer. The application reads the stream of data from this buffer. Okay. In the next video, I'm going to explain about the TCP segment structure. Thank you.